In this video, we will see Ohm's law, electrical resistance and dimension of resistance. In 1828, Georg Simon Ohm, a German physicist and mathematician, found that at a constant temperature, that is, when the temperature is kept unchanged, the current I flowing through an electric conductor is directly proportional to the potential difference V between its ends. That is, I is proportional to V, or we can write V is proportional to I. When two variables are directly proportional to each other, if one variable increases, other variable also increases, and if one decreases, other decreases. Here we can say that if voltage or potential difference increases, current increases, and if voltage decreases, current decreases. You know, when two variables are proportional to each other, then in order to define their relationship, we have to introduce a proportionality constant. Then we can write equation 1 as V is equal to IR, or V by I is equal to R. Here, R is called the electrical resistance, or simply we say resistance. It is the property of an object. When a current flows through a conductor, the resistance of the conductor opposes the flow of current through it. Now, what is the unit of resistance? The SI unit of resistance is ohm, denoted by the Greek letter omega. We can say resistance of a conductor is 1 ohm if the current of 1 ampere flows through the conductor when a potential difference of 1 volt is applied. Now, let's derive dimensional formula of resistance. You know, resistance R is equal to V by I. So, the dimension of resistance is equal to dimension of voltage divided by dimension of current. Let this be equation number 1. If we want to find out the dimension of resistance, we need to find out the dimension of voltage and the dimension of current first. Let's see what is the dimension of voltage. Voltage V is equal to electric field into distance, and electric field is equal to force divided by charge. So we can write voltage as V is equal to electric field into distance, that is equal to force divided by charge into distance. To find out the dimension of voltage, we should know the dimension of force, charge and distance. First, you know, force is equal to mass into acceleration. Therefore, dimension of force is equal to dimension of mass into dimension of acceleration, which is equal to dimension of mass is m multiplied by dimension of acceleration L t raised to minus 2. So, we get dimension of force is equal to m L t raised to minus 2. This is equation number 2. Here m is the mass, L is the length and t is the time. Next is charge. Charge is equal to current into time. Therefore, dimension of charge is equal to dimension of current into dimension of time. That is equal to dimension of current I into dimension of time t. Here I is the current. This is equation number 3. And dimension of distance is equal to L. That's equation number 4. From these equations, equation 2, 3 and 4, we get the dimension of voltage is equal to dimension of force, that is mL t raised to minus 2 divided by dimension of charge, that is IT into dimension of distance L, which will give us mL square t raised to minus 3 I raised to minus 1. Let this be equation number 5. And finally, dimension of current is equal to I, equation 6. Now, we have dimensions of both current and voltage. Substituting equation 5 and 6 in equation 1, we get dimension of resistance is equal to dimension of voltage ml square t raised to minus 3 I raised to minus 1 divided by dimension of current I, which is equal to ml square t raised to minus 3 I raised to minus 1 divided by I, that is I raised to minus 2. So we get dimension of resistance is equal to ml square t raised to minus 3 I raised to minus 2. That's all for this session. I hope you found this video helpful and informative. In that case, you can share it with your friends. Also, do like and subscribe the channel. Feel free to ask doubts in the comment box. You can continue learning this chapter by clicking this link. Thank you.